Okay, so let's do two more examples where we graph the polynomial. And what we want to do, remember, is complete the square. So let's go ahead and look at this problem and complete the square. So first, factor out the 2. Okay. So apply the completed the square to the x part with the 8 by dividing it by 2. Squaring it. If we add it, we also subtract it. Okay. Again, the first 3 parts is the perfect square. So we get x minus, and 8 divided by 2 is 4. All squared. The 2 also comes down. And remember, we haven't touched this yet. So the 2 needs to be distributed to that part. So this is negative 2 times 4 squared plus 33. So go ahead and simplify everything so that it's written nicely. X minus 4 squared. This is 16 times 2, which is negative 32. So negative 32 plus 33 is 1. Okay. Once it's in this form, let's go ahead and answer all the questions that we need, which is find the vertex. So the vertex here is 4, 1. The a value in the front is positive, so it points up, or the bowl is upwards. So this vertex is a min, because it goes like that. Now to find the horizontal and vertical intercepts, we plug in the way that we're supposed to. So 1, 2, 3, horizontal intercepts, and then vertical intercepts. So the vertical intercept, again, is given by 0, something. Horizontal is something, 0. So the vertical, we plug 0 in for the x, and that again works best in the original. So if I plug 0 into here, we get a 33. The horizontal, though, is plugging in for y, which is going to be easier here. So what I'm going to do is I'm going to say 0 is equal to 2 times x minus 4 squared plus 1. Solve. Negative 1 is 2 times x minus 4 all squared. Divide both sides by 2. And then apply the square root property. So x minus 4 is equal to plus or minus the square root of negative 1/2. Now, we could continue if we wanted to, but you can actually stop right here if you understand that this is an I value, right? This can be simplified as plus or minus I square root of 1/2. I values are not graphable for our purposes on the real plane or the xy plane. So we're going to leave it like this, and what this tells you, when you have this I value, that there are no horizontal intercepts. And what that also says, remember, no horizontal intercepts, it does not touch the horizontal axis. So let's go ahead and graph this using that information. So I'm going to have to scale it, right, so that I can get to that 33. So 10, 20, 30, 40, 0, 33 is right there. We also know that the graph points up and has a min at 4, 1. So 4, 1 is down there. And our graph looks like that. Sorry, it should be symmetrical, so let me go ahead and redo that a little bit. So notice that you could tell that if you didn't even solve for this horizontal intercept and you actually just drew the graph or knew where these points were. So you knew that 4, 1 is here and that the graph pointed up. Is that pretty clear that it would never hit the horizontal axis? That would also give you the solution where it says no horizontal intercepts. So you can get that directly if you want as well, or algebraically. So this is an example where we have no horizontal intercepts. Let's do another example to show you the third case of the horizontal intercept. Notice that this is already in the form of the h and k. So here, what I'm going to do is I'm going to rewrite this. So we can see that h is going to be, h is going to be -2 and k is going to be 0. Now remember, the original form was a times x minus h squared plus k. So you need it to be a minus in the middle. So the minus here gives you a -2 because -2 is +2. So using this now we can answer our questions. 1, the vertex is at -2, 0. The a value is negative, so it points down. So there's a max at -2, 0. And then find the horizontal intercept and the vertical intercept. Again, horizontal intercept is at something, 0, and 0, something for the vertical. Horizontal intercept, plug 0 in for y. 0 is equal to -1/2 times x plus 2 squared. So if I divide both sides by this -1/2, you get, let me write it over here. You get 0 again, x plus 2 squared. And if you take the square root of both sides, you get plus or minus the square root of 0 is x plus 2, or x is equal to -2 plus or minus the square root of 0. So again, this happens, you get this -2, but its multiplicity is 2. So it only hits the axis at this one point, which is going to be -2, 0, and it does it with multiplicity 2. Now let's do the vertical one, where 0 is x. And in this case, you just have to evaluate the arithmetic, right? So 2 plus 0 is 2, squared is 4. So this is a -1/2 times 4. These two simplify as just 2. So this is -2 as well. So this one is vertical intercept 0, -2. So let's go ahead and graph all the information. We want -2, 0. And we want 0, -2. Okay. This is the vertex, right, as well as the horizontal intercept. So we know that it has a bull which is attached to this point. Now the question really is, does the bull go like that? Or does it go like this? Now remember, it has to go through this point. So is that okay to say that the blue part is the actual graph that we need, not the one on the top, the green? Because this bull will never dip back down to hit that dot. So this green one is not the answer. We want the blue one. And this is the graph of the parabola given by y is equal to -1/2 times x plus 2 all squared, where it only touches the horizontal axis at one point, which is given by -2, 0.